The mean, median, range, etc. are all examples of numerical measures. These are statistical properties that allow statisticians to better understand, interpret, and make predictions on data. Right, so on numerical measures, it's split into two main categories. You've got measures of averages and measures of spread. Measures of averages are such as like mean, median, mode. The measures of spread, you've got the range, the interquartile range, the standard deviation, and the variance. Now the mean, this is often referred to as the arithmetic mean, and this is simply just taking all the values, adding them all together, and dividing by how many there are. The median, this is where you put them in ascending, or it could be descending order, and then you simply take the middle value, like so. And the mode, this is the most occurring value, the one that occurs the most. And you can have situations where it's bimodal and so on. For measures of spread, you've got the range. This is where you take the maximum value in your data set and you subtract the minimum value. The interquartile range is similar to the range, except for it takes off the top 25% of the data and the bottom 25% of the data and works out the range in between. So this is often referred to as Q3 take away Q1, your quartiles. The standard deviation and the variance, these are a little more difficult to understand. Probably the best way to think about it is it's like the average distance from the mean of each piece of data. Now obviously our calculators calculate all this for us, but if you want to know how it's worked out, you simply, for example with the variance, you're going to take the value of x bar and you're going to take values of x, so all the values in the data set from the mean, you're going to square the difference, add them all together and divide by how many there are. And we're going to come on to this formula a bit later on in this video. But that's how the variance is worked out, and a standard deviation, as you should know, is just the square root of the variance. Right, so let's have a look at the various different ways they can present data to you in a question. The first is it could give you values as a list or a frequency table. So we can see in this example, we've got a list of values here, and all we're going to do is plug them into the calculator, and that will give us our numerical measures. And then in the second example here, you've got a frequency table. Again, just plug them in to the calculator and it'll do all the work for you. The second way they can present it is a frequency table, but it's grouped data here. So rather than saying the number of days and it tells you the actual daily number of letters, instead it says from 0 to 9 and 10 to 19 and so on. Now the way you go about calculating this is you're going to take the midpoint of the group data. So in this case, 0 plus 9 over 2 is 4.5, so the midpoint will be 4.5, and that will be the number that you input into your calculator for the first bit, even though 4.5 doesn't make sense in context of the question. The third way that you can present it is where you've got some values that don't have a lower bound or upper bound. So for example, in this question, we can see it says less than 239 and more than 259. If we take the more than 259 one first, we don't know whether that's 260 or 260 million, 260 billion. We don't know because it's got no upper bound. And because of that, we can't work out the midpoint. Now the way we go about this is we just choose any value. So for example, any value less than 239, put that into the calculator. Any value greater than 259 and put that in. But on these questions, it will only ever ask you to work out the median and the interquartile range, or possibly the mode. The reason for this is because they are not affected by the extreme data, the values on either side. If you want to work out the mean or standard deviation, you will always be told what these actual values are. And it's common in these questions that on part B or C it says, we now know that the value less than 239 is this, the value more than 259 is that, and then you change your numbers in the calculator to those values you've been told, and you can work out the exact mean and standard deviation. And the fourth way that you could be given it is rather than given as a list or a frequency table like we saw before, they might give you these summation signs. And all you need to realise is this is just another way of calculating it. And quite often I get you to do the mean and the standard deviation, or the mean and the variance with this. The variance equation is in the formula booklet, so s squared is equal to sigma x minus x bar all squared over n minus 1. And if you want the standard deviation, you just square root that. And the mean one, unfortunately, this isn't in the formula booklet, but it's relatively straightforward to understand. It's just sigma x over n, adding all the values up and dividing by how many there are. In this case, this question in particular, it's in terms of y, but it's the same approach, just y instead of x. Okay, so to calculate with our calculator, the first thing we're going to do is from a menu, go to Stat, so number 2 on here, and then you'll come up with all these lists. Now if you've got any data on here, the best thing to do is delete it. A quick way of doing that is to press F6, go across, F4 is delete all, and then just F1 to accept, F4, and then it's clear, and then we can press F6 to go back across. Now before we calculate anything, we should just check it's in the right mode, and the way we do that is F2 for calc, F6 for set, and the way that I'm going to be showing you to do this, it should say list 1, list 2, list 1, list 2, 1, and it should never change from that. If you've got a factory setting, it may actually say 1 in the one variable frequency column, so just change that to list 2. If you're happy with that, press exit to come back and exit again, and now we're going to input all our data. So say we're just going to put in a load of numbers across here and so on. Now list 2, this is going to represent our frequency column. So say I'm just going to put a 1 in all of these. So 1, 1, 1, 1, and hit an executor to do it. Now I've deliberately left a few of these blank to show you an error message that comes up a lot. So the way we're going to do this, we're going to press calc and one variable, and what we'll see is let's say dimension error. So if you ever get this in an exam, this simply means that there's one of your rows doesn't have a value in both of them. So for example on my one here you can see 8 doesn't have it. So I'm just going to put number 1 there now, and it should work. So again I'm going to go to calc now, it's one variable we're always doing for this, and here's all my data. Now from here we've got x bar, this is your mean, and the next two aren't really useful. The next ones we're looking for is sigma x and sx. Now these are your standard deviations. Officially speaking, your sigma is your population standard deviation and your s is your sample, and you're meant to choose which one depending on the data set that you're being given. Although in S1 it doesn't make a difference, they'll accept either answer, so we'll just put one of those two down. And the next ones you're after, n is obviously the number of things. Q1 and Q3, these are your interquartile range, and you need to list these. So for example, to work on the interquartile range, you write down Q3, which is 7, Q1, which is 2, so the difference between them will be 5, so the interquartile range is 5, and you have to write down Q3 and Q1 in the examination. The range, it doesn't actually tell you the range, although it does tell you the maximum value and the minimum value, so again, so just subtract these to get this. And the median, as we can see, is 5, and then the final one that we can get is the mode. Now the reason why this is listing load of modes here is because, well, there isn't a mode with the data set that I put in. They're all got the same amount of values. So obviously we wouldn't write down a mode here, but in the case where there is, so if I just change one of these to a 6, for example, then when I go down to mode now, it should say the mode is just 6, and I can put these in. The only variation to this is with the frequency table. You might say, for example, 1 occurs 5 times, so you might change your frequency. This might be 11, that might stay as a 1, that might be 7, and so on. And it just means you get slightly different values, but the same approach and the same answers. Let's see how change of scale affects numerical measures. Let's say you've got a question where you've got a mean, standard deviation, etc. And now you're asked to change the scale of the question. Well, the way that you change the scale affects the numerical measures in different ways. For example, if you add or subtract a set amount to all your values, then your averages will increase or decrease by that set amount. So say you add 10 to all your values, then your mean is going to be 10 bigger. Whereas your measures spread, your ranges, your standard deviations, etc. remain exactly the same. They don't change. Alternatively, if you multiply or divide by a set amount, a scalar value, say you end up making everything 3 times as big, your averages will end up 3 times as big as well. And your measures of spread will also end up 3 times as big. The only thing that's different to this is the variance. The reason for this, the variance is actually affected twice because it's standard deviation squared. So say you made everything 3 times as large, your standard deviation will be 3 times as large, but your variance will be 9 times as large because it will be 3 squared. Let's see some examples of these. So in this one, in June 2014, we've got here, and it says, for each week, for the 35 weeks, Henrietta sells 60 eggs to a local shop, keeping the remainder for her own use. So this means all the values we worked out earlier on, we're going to be subtracting 60 from them. Now in part A, we worked out the mean was 70.4 and the standard deviation was 2.03. Now based on this information in part B, the new mean is going to be subtracting 60, so we're going to get 10.4. Whereas our standard deviation is going to remain exactly the same because we're adding or subtracting. The second question, June 2010, we got here. We've got all these, and you can see at the very top it says he then subtracted 50p from each price, and the resultant differences in pence were these. And in part AII, hence calculate the mean standard deviation of the prices paid by Eduardo. So in this case, we're going to be adding 50p to these values. Now earlier on we worked out the mean to be 1.5 and the standard deviation to be 11.7. If we're going to add 50p, that means our new mean is going to be 51.5, but just like earlier on, our standard deviation is going to remain unaffected. If we move on to part B, however, now it's talking about an exchange rate. So we're coming from pounds to euros, and in order to do this, we're going to times by 1.22. Now, because we're multiplying by a scalar value, both the averages and measures of spread will change. You may notice in this question, I've changed my answers from pence into pound so that I can get into euros a lot easier. And the final one we're going to have a look at is June 2015 here. And again, earlier on in the question, we worked out the mean to be 68.3, the variance to be 2.42. And it says, given that 1 inch is equivalent to approximately 25.4 millimeters, calculate the new mean and variance. Now, to go from an inch to a millimeter, or millimeters to an inch, we're going to divide by 25.4. So our new mean is going to be 68.3 divided by 25.4, which in this case is 2.69. However, the variance, if you remember earlier on we were talking about it, you have to divide by it twice. So we're going to be dividing by 25.4 squared. And in this case, we're going to get 0.0037. It's not often in questions when you're asked to make a comparison between two sets of data based only on numerical measures. But in the rare cases that you are, it's important that you make a comment on your averages and a separate comment and comparison on your measures of spread. Things to take into consideration here: your measures of averages, they generally tell you how much better, bigger, higher, more expensive something is. Whereas your measures of spread, they tell you about how spaced out the data is, the consistency of result, the variation within your results. Important points to remember when you go into the exam. The first of which is change of scale. So remembering how this affects different scenarios. So for example, if you're adding and subtracting, your averages change, your measures of spreads don't. If you're multiplying and dividing, it all changes. And the one thing to remember is the variance is affected twice in this case. The second one is the formula. If you get a question where it's got the sigma notation, remember that you can refer to your formula booklet for this, the variance and standard deviation, whereas you need to remember how to work out the mean from this, sigma x over n. The third one, this comes up time to time. It might say, explain why the mean or standard deviation that you calculated earlier on is an approximation or an estimation. And this will almost always be because you've got group data. And what you've done with that group data is you've taken the midpoint and you've assumed that all those values are the midpoint. And because of this assumption, it's an approximation. Another thing that could come up is, what is the best measure of average or spread? Now, generally speaking, the best measure of average is the mean, and the best measure of spread is the standard deviation or variance. The reason for this is it takes into consideration all of the values of the data. However, in cases where you might have extreme data, so a big outlier, a very big number or a very small number, then your mean and your standard deviation will be affected by this. And in these situations, the median or the interquartile range may be considered a better measure of spread and average because they are not affected by this extreme data. Another one that can come up, it might say, given that the true mean is this, comment on if the sample was likely to be random. Now, it's quite a rare question, this. But generally speaking, if you know the true mean and you've got a sample mean and they match up quite nicely, then that means that your sample is quite a good fit for the population. So it's likely to be a random sample. Whereas if they differ by quite an amount, then that means that the sample doesn't seem to be a good fit for the population. So in this case, you'd assume that it's unlikely to be a random sample. And lastly, point 6, it's when you're comparing two sets of data. Now remember that you must make a separate comment on your measures of averages and another comment on your measures of spreads.